All right, today we're going to be learning about savings and compound interest. So your personal living and finance teacher asked you to determine which of two plans will yield more money by the time you retire. So option one, you deposit $500 at the end of each year into an annuity at 6% interest compounded yearly for the next 40 years. So you might not know what an annuity is. It is an interest earning account. So most of your, if you have a savings account at a bank, that's an annuity. There's a bunch of different ones out there, but a savings account is the most common. So option two, you save money for 20 years and then deposit $20,000 into an account that pays 6% interest compounded yearly for the next 20 years. So the first option, you're putting money in a little bit every year for 40 years. Option two, you're saving for the first 20 and then putting it in the account for the second 20. So we're going to be using the TVM solver on our calculators. So it's called TVM because it's time, value, and money. So it's looking at the time, over time, how much value does money become. So to bring up the TVM solver on your calculator, you're going to push the apps button, which is right next to math. You're going to choose enter on finance and then push enter on the TVM solver. And you will see the screen that is on the paper. So let's look what each of these stand for. So N is the number of compounding periods. It's basically how much time goes by. It also has to do with how many payments you're making to the account if you're making payments. I% is the interest rate. You're not going to change it. You're not going to change it to a decimal. You're just going to put it in exactly what it says in the problem. PV stands for present value. That's how much money you're putting at the account at the very beginning. PMT is your payment amount. If you're making payments to the account every year, how much are you putting in? Future value is how much money will be in the account in the future. PY and CY are payments per year and compound periods per year. And like 95% of the time, these two numbers match. Every once in a while, we have problems where they don't, and when we get to that part, I'll show you. So let's fill in what each variable would be based on option one. So N, the number of compounding periods. So we are compounding our interest yearly, and our payments are being made each year. So those, because it's each year and yearly, that makes our lives easier. We just need to know how many years are going by, which would be 40. I%, the account is earning 6% interest. PV, there's no money in the account when we start, so $0. PMT, we're paying $500 into the account each year. FV, that's what we want to know. We want to know how much money is going to be in there in the future. We are making one payment per year, and our interest compounds each year. Now for PMT, if you look up here, you have two options. It's either end or beginning. Unless the problem says at the beginning, it's going to be end. Also, our problem states that at the end of each year. So now let's go back to our calculator and we're going to put these in. So 40, 6, 0, 500. Wherever the question mark is, you'll leave it as a 0, or you don't have to touch it at all. 1 and 1. So everything's set up. So then I'm going to go back to FV, because that's the one I want to find. And I'm going to push the green alpha button, and then enter, and it's going to change. And it becomes, now it's negative. The app's a little bit weird because it's intended more for having a starting balance and making payments and paying something off. So we're just going to ignore the negative in this situation. And so that's telling us that at the end of the 40 years, our account will have $77,300 $380.98. So what about option 2? Option number 2, the money is only in the account for 20 years. We're still getting 6% interest, but this time we're starting with $20,000. We're not making payments, so we're going to put a 0 there. We want to know the future value. And then since we're not making payments, but the interest is compounded yearly, these are still both 1. And then we'll put it in as end. So back to the app. I'm going to go back up to the top. 20 years, 6 payments. Our PV will be 20,000. PMT is 0. And then again, because I want to know the future value and the bottom's all set, I'm going to push alpha, enter, and it's going to change. That's how much I'll have in my account. So $64,142.71. So which one was the better option? Option 1 gave us more money by $13,000. That's a big difference. I would much rather have the account that has $13,000 more dollars in it. We also, in option 2, we would have had to save $1,000 every year, whereas in the first one, we were only putting in $500 each year. So we actually put less money in and got more money out, at least per year. How much interest was earned in option 2? Well, we ended up with $64,142.71, but $20,000 of that we put in to begin with. So we made $44,142.71 in interest. So basically, your interest equals your final minus your deposit. What would happen to our answers if the interest was compounded monthly instead of yearly? Well, the more often you're putting interest into your account, the more money you're going to make. So we'd earn more money. So if instead of monthly, we did weekly, we'd make even more money. And if we did daily, we'd make even more money. So let's look at another type of problem. How much do I need? After some careful research, Archibald estimated that he will need $20,000 a year at the end of each year for 20 years to supplement his income. So his pension and Social Security during retirement, he's going to need an extra $20,000 a year. Archibald's annuity will earn 5% annual interest compounded annually during the payout period. How much money will Archibald need in his annuity at the time of retirement to receive his $20,000 a year? So what we do know, it is going on for 20 years. He is getting 5% interest. We don't know what the account is at the beginning. That's what we want to know. He's going to make a payment of negative $20,000 each year because he's taking $20,000 out of the account. So that's why it's negative. At the end of his retirement, he doesn't want any money left in that account because when your retirement's over, you're probably dead, unfortunately, and therefore you don't want money left over. He's going to get one payment a year, and his interest is compounded once a year. And he's going to take the money out at the end of each year. So we are looking for PV, the present value. How much does he need to put in at the beginning? So let's go back to our app. 20 years, 5% interest. We don't know how much we're going to put in at the beginning. We know we're taking out $20,000 and we want nothing left over. So if we go back up to PV, alpha, enter, we need to start off the account with $249,244.21. That's how much he needs to have in his savings to be able to get $20,000 out each year. Planning ahead. A local bank is offering a 60-month certificate of deposit at a rate of 5.7% compounded monthly. So that's going to be important. That's a little bit different than the other ones we've done. How much must be invested now in the CD to accumulate $6,000 at the end of 5 years? So we know we want to end up with $6,000. We're going to make 5.7% interest. Because it's compounded monthly, CY will be 12. PY will also be 12 because we're not making a payment to the account, we're just putting money in at the beginning. How much money? We don't know. The PMT is going to be end because it didn't say anything about beginning. So N is the number of months because it is monthly that the money's in the account, which in this case would be 60. That's the same as 5 years because 5 years times 12 months in a year is 60. So back to our app. It's in there for 60 months. We're going to get 5.7% every month. We don't know how much we want to put in. We're not making any payments, but we want to have $6,000 at the end. And these will be 12. And the nice thing is the calculator knows that those two are usually the same because if I push enter after putting 12 in PY, it will change CY to 12 for me. So go back up to PV to see what we need to have at the beginning. Alpha, enter. We should put in $4,515.13 to start the account. And that's all for today.